हेलो एंड नमस्कार, वेलकम बैक टू माय चैनल गाइस। और आज की वीडियो में हम बात करने वाले हैं सिस्टम कमांड्स के सबसे पहले चैप्टर की। एंड द चैप्टर इज बेसिकली इट विल टीच यू कि हाउ टू रन अ लिनक्स सिस्टम। ओके, basically how to transverse through files, how to read a file, what are the permission thing, how to copy a file, move a file. So all those basics cheeses what we do to basically run a operating system we will be going to learn today. Okay, as a matter of fact, I just wanted to tell you that if you go and search for like top 10 computers in the world, then you will find that just Linux is the one who is like all those 10 computer systems are basically Linux. Okay, so that's why it is important to learn Linux. Okay, so let's go to our computer screen and just start learning it. Okay, so at my computer screen you are seeing structure of a command. So firstly we will discuss like what is the structure of command, and one more thing that I am going to go through all those command whatever we are going through on this VS Code terminal. It is a bash terminal you can see here, so I guess everything will be running fine here. Otherwise I have my college terminal also open, like it is a virtual access, okay, virtual machine access, where I have logged into my SSH cell. Okay, so first we will discuss the command. Okay, structure of a command. So you can see this, and you can see here as well what it is same. Yeah, so here this root. Okay, if you come to this picture, this user, okay, this is basically the username. So if I say this is my username. Okay, here also you can see this is my username. After that there is a @ symbol, and then there is machine, which is a host name. So if you see SE2001, it is the host name. After that I have this double colon, then we have the path variable where we are currently. So where we are currently we are here. So if I ls this, so I have something here. I just do let's say key, I just go to one folder, and you can see here our path got changed, correct? Similarly I can go to cd slash, and you can see that our path got changed to slash. Okay, so that's how this is the path. After that, whatever we are writing, like whatever we were writing, ls-a or something, so this is our command, and this -a is basically the option or arguments you can say. Okay, now if I want to know like which command what it does, okay, so I just simply go on man is a command which is a manual command which can give you a documentation, a manual about any command. Just like I search for ls, man for ls, so ls, the manual is saying that it lists the directory's content, and there are many other things as well, like /f. Okay, immediately after the path name, this an asterisk after each time that executable, and at a sign. Matlab, if you can like going to read all this stuff, then you will know that what it does. Like ls is useful in so many other ways, like for each file print the file serial number, that is inode number. Okay, so we will be going to discuss what is inode number. So there are many things from this also which is very useful to us, and we are going to learn now. This is basically something is a manual. So to exit out, okay, we have to just tap q, and it will exit out from menu. Okay, so man and command will give you the manual for the command, example man.ls. Now there are many commands. Okay, there are many commands you can see this time. Also, before going that, I would just like to tell you a concept, that is hypervisor. Hypervisor is a software, firmware or hardware that allows multiple virtual machines to run on a physical machine. Okay, so basically this is a software, firmware, hardware which using which we are able to run VMs, multiple VMs on a single machine. What it does, it creates and runs VM and allocate resources like CPU, memory, and storage to each VM. Sorry. Okay, so you got it. Like what it does create and runs those VM. Other names of these are VMM or virtualizers. How it works, it just isolates VM from the physical hardware, allowing for more efficient use of resources. Okay, use cases and benefits, you can read it out. I'm not going that much deep into it. Then we have many commands. We will going to see all of these. Okay, but first let's go to the theory part. So let's discuss about the file system hierarchy. Okay, like what is the file system hierarchy standards, and this is according to file system hierarchy standards 3.0, which was released in June 3, 2015. Okay, and according to this, we have this type of file system, that is / that is the shell directory. If I go here and let's say just I am at here, okay, cd / home directory. Now you will see all these files here. So just let's do ls. Ls is basically for listing all the directory, and you can see all these files. Okay, there are many like bin, dev, home. So you can see bin, sbin, etc, dev, proc, var, temp, user, home, boot, lib, opt, mnt, that is mount, media, and server. And these are all the stuff written here ki which directory is basically folder, so which folder contains what files. So just like /win contains user binaries, swin that is system binaries, okay, system related binaries. /etc is basically etc directory is basically taking care of configuration files. Sorry. Dev is a folder which contains device files, is whatever device we connect. Proc is basically contains process information. Var contains variable files. Temp contains temporary files. Okay, it is not like we usually do clean these temporary files. /user will contain user programs. /home is a home directory. Boot is bootloader files, whatever basically required to load up our system. Lib is basically system libraries. Opt is optional add-on apps, whatever other apps is there. mnt is mount directory, whatever like pen drive you attach. So all those mounting things files are here. Media is basically removable device, USB pen drive related stuff. And SRV is basically service data. Okay, so this is basically hierarchy. And these are the stuffs which is written in great detail. You can read it out. Like /win is the essential command binary. Boot is static file of bootloader. Dev is device files. etc is host specific system configuration. Lib is essential shared libraries and kernel modules. Media is mount points for removable devices. mnt is our mount points. And opt is basically add-on application for software packages. Then there is run, which is basically data relevant to running processes. swin essential system binaries. srv data for services. Temp for temporary files. User for second. This is basically secondary hierarchy in our file system. And var is basically variable data. So as I said, what is it? It is a secondary hierarchy. Our this whole thing was the first hierarchy system, that is file system hierarchy. Inside that there is second hierarchy, and let's discuss about that. So /user is a second hierarchy. If I go to cd.user usr and I did just ls, you can see these much things. Okay, so cd basically is used. Cd is basically change directory. Okay, cd command is change directory command. If you don't getting it, don't worry, I will explain everything. Okay, so user hierarchy, you can see /user/bin. There is a win folder. Okay, what it contains? It contains user commands. Then there is a lib folder inside user, that is libraries. There is local, which contains local hierarchy. SBIN, which contains non-vital system binaries, which is not like that much important for system, related to user binaries. Share architectural dependent data. Include is basically header files included by C programs, and SRC is basically source code. Okay, so these are basically hierarchy of user. There is one more hierarchy. I said variable data. It is also a hierarchy, and let's see about the var. So what I will do, I just go to var folder. Var folder is there, but I am currently in /user folder. So going back to parent folder, I just have to do cd space dash, and I just did the ls, and you can see I am here. Just let me clear the screen by saying clear, and just listing all the file again. So I am here right now. I have to go to var folder. So I will just cd var. I will just do clear and then the ls file. So you can see backups, crash, local, log, opt, snap, temp, cache, live, block, mail, run, smooth, and many other things. So what are those things? So basically cache is basically what? It contains application cache data. Live is basically variable state information. Local contains variable data for user local. Okay. We have a folder in user /local also. There is log folder which contain log files. The log is there which contain log files and directories. A run file is basically containing data relevant to running a process. And temp file is again temporary files preserved between reboots. Okay. Now there are two things. One is shareable file and their other is non-shareable. Okay. And the definition, broad definition of shareable and unshareable or non-shareable. The shareable files are these files can be stored on one host and used on others. That is the shareable files. It is stored in one host and that can be used on other systems as well. For example, files in the user home directories are shareable. So /user is a shareable directory. Whereas unshareable are these files are not shareable. For example, device lock files are not shareable because these are, let's say, crucial for my system. Right? This is system dependent. Okay. So if you talk shareable, so static, there are also static and variable. Shareable, like some shareable file that is static as it is, it won't going to change. And there are some files which is let's say shareable, okay, but it is variable also, like it will vary also. Okay, so static is files are basically /user and /opt are static shareable files, and variable files which are shareable is basically var and /mail. So inside var folder we has mail folder, which is a shareable variable folder. Okay, it is a variable, it can change. Whereas unshareable folder is basically etc. Okay, and the boot and the unshareable, and these both are static folder, that is it is not shareable and not going to change. And there is variable folder that it is not shareable, but it is going to change. That is run and lock. Okay, /var run /var lock. Now file sharing allow multiple people to use the same data file. Okay, access permission determines whether the user can create or modify files, or if they have to read access or no access at all. Shared file system can improve performance and scalability, and can reduce the time administration spent on managing data. So this is the benefit of shareable file system. Okay, but as you will know, you don't need to share everything, right? Now transversion tree, like how we will transverse. So / is there, is the root of the file system. Like I just did cd space / and I just came to root folder, right? This is my root folder. If you can see, this is my root folder. So what I did, I just did cd or plus share /. Okay, I just did cd and / space after space, and I will come to root folder. Okay, I just root folder. Now I just want to go to current directory. Okay, that is the dot is representing current directory. So if I say, let's say A, you can see here is a dot, which shows that I am at this directory, current directory. Okay. There is also double dash, which says it is a parent directory. Double dash is a parent directory. So if I say clear, let's say let's go here and let's say clear. ls is basically we are here. Let's say we go to opt, cd opt. Sorry, clear, then cd and then opt. Okay, where I am at cd. Now I just do cd and dash where I am right now to that particular folder, right? In same the folder. Now if I do cd dash dash, where I am now? First I was in opt folder. Now I am at root directory, that is slash. If you are not believing, ls is the root directory. So this will help to go to back folder in which we were. And this is basically the current folder, and cd is basically to change directory to whatever directory I want to go. Like if I want to go to where directory, I just say cd and change directory to where. I can go to like inside the where. Let's say inside the where these are the file. I just come to parent directory, so you can see that I am at root directory. I want to go to where slash opt. So I will write cd where slash opt, and I came to this directory. So I can use slash to go to inside and inside. Okay, so cd space and cd space, and I am back to home directory, root directory, you can say. Correct. Now there are files notations, okay, which I just wanted to know, let you know. So if we run a command, let's say ls we were running and we are getting something like this. Now there is something else with the als, and that is dash a or dash l. First we will discuss about dash l. Okay, so ls dash l will show you this type of structure. Okay, now some things to notice here. Okay, just let me take it to this side. Now here you can see something like this. Okay, same thing here. This drwx and all these stuff you can see. Okay, so this first things which you are saying like these. Let's say I'm saying all these. Okay, you are saying this. So what these are? These are basically the permission. Okay, here d represents the directory file. Similarly, there are other characters which shows the file type. So basically, if you can see here, it starts with d, but it starts with l. Okay, you can see d, l. So d is basically a directory. What d represent? A directory file. Where this l. Okay, so there are many other things. Let's say l. L is basically symbolic link. What is symbolic link? We will come to that. Don't worry. So you can see L starting with L. So you can see this file L, that is a symbolic link, and you can see here that this is a svin folder, and this arrow shows this svin is basically linked to /user/svin folder. That is, it is the location of this particular folder. So it is a symbolic link. It is a symbol which is linking to that particular folder here. You can see here as well. You can see here as well. Okay. So all these are symbolic. Similarly, there are C. C starts for character files. B for block files. If permission starts with S, that is socket file, and P starts with named pipe. Okay. So here are only two things like D, L. Okay, but there will be C also. So, and also one thing here, the C and D. The C character file and D directory file. These are basically device files. Okay, so character file is basically, it consists characters, okay, of particular file, and D is basically our directory. And this lock and dash is basically linking to, symbolic link that is linking to run/lock. It is lock is saying that if I click on this, it will redirect me to, it will take me to this run/lock. This arrow shows that this directory is a link to some other directory, like in lock directory is linked to run lock directory. That is, this directory is linked to this directory. That is symbolic link. Now, if we talk in detail about this particular, let's say, one line, okay, this line, just let's take a one. So first thing first, D, as I said, D is what? D's are file type, right? Then there is these three. How much? This three, first three, this three. These three is basically our owner permission. What it is? It tells that what an owner can do. Like if I have, the first is write, correct? It is write. Read. So read matlab a user can read. Then there is a write, means not user, it's owner. So owner can read, owner can write, owner can execute. X is basically execute. Similarly, we have second one, again 3 characters. It's the permission of a group. Okay, it is permission of a group, and it is like what a group or a team can do. It can read, it can't write because there is no permission at all, and it can execute. Group can execute and read, but it can't write. Okay, then there is third also, and this is basically others permission, other users permission. Other user, what other user can do? Other user can read, can't write, but can execute. So this is basically the structure, permission string. Basically, this is known as permission string. We will discuss about it also. Then there is something called 5. What 5 representing here is the number of hard links. Okay, what hard links? We will talk about it. Don't worry. After that, we have the name. Okay, if you see root is the name of username. Okay, so it is basically the owner's name. Then there is another one which is basically group name. So I am a root user, owner is I am a root user, I belongs to a root group. Okay, any admin group. After that, we have numbers, that is basically the size. How much is the file size? You can see here. This is the file size. After that, we have the last modified timestamp, and then we have the file name. You can see here as well. This is the time last modified, and this is the obviously the file name or directory name, as you know. Now I am saying that I will talk about hard link, soft link, and all this. So there is concept called inode. So just let me take something called sbin, okay, and just do ls. I just clear it, ls/i, and just type sbin, and you can see this much of stuff. Okay, I just think I should do some other folder because there are many files here. So ls/i, and I will say let's say opt folder, and you can see we got this. So what here it is a directory. Let's say asset is the directory, and there is a number associated with it. Similarly, iris is a directory and there is a number associated with it. Repository is a directory, there is a number associated with it. You can see that numbers, number and directory, number and directory. Similarly, number and directory. You can see all these things. Okay. So inode or index node is a file data structure that stores metadata about the file in a Linux system, and it is unique for every file. So if this is the inode, this is the inode, and what it does, it is a file data structure. It is a data structure that stores the metadata about the file in a Linux file system, and it is always unique for every file also. What it stores? The inode stores information such as file size, file type, file permission, timestamp, owner and group information, location of the disk. So basically you can see the main thing is location of the disk. It stores inode. And you can see something like this is showing here. Okay. Now I as I said, what is hard link and inode? Symbolic links and inodes. There is two things, hard link and soft link. So what is hard link? Hard link is basically the point to the same inode. Okay? And soft link is basically points to some hard link. Okay? Means this is a directory and this is its inode number. Okay? But there will be this is a hard link, that is a file have unique inode number. Okay, there will be another file which will be a soft link. And why we are going to call that particular file a soft link? Because that will have a same inode number as this, which means that this hard link is unique and this soft link is basically a point which points toward some hard links, which links to some other file. Okay, that is the same. That is hard links and soft link. So I hope you got it. Now let's talk about permission string. Okay, what is this permission string? So if I go back ls.l and you can see this permission string, and I just discussed like what this thing is. Just here ignore one of these. Okay, I just draw it by click. Mistakenly I draw it 4, but it will be 3 only. I just deleting it. Okay, so first 3 is basically owner permission, then 3 is basically group permission, then 3 is basically other permission. And similarly this is a string. Okay, and you can convert this string into integer, and for this particular string the integer form is basically 755. What it is? 755. Okay, you got it. Now how it is coming? So we have this table. So understand, I just giving you some tip like how you can remember this. So you can see there is nothing at the first, nothing at the second, and nothing at the third. So where there is no permission available at that particular position, that is 0. If there is a permission, it is going to be 1. So you can see here it has executable permission, and executable permission is always third. So you can see here it has 1 at here and other is 0. Now if we convert it into binary, so basically decimal form, you will get 1, right? Similarly, you can see second place is 1, other is 0 and 0. So it is 0, 1 and 0. And this is binary, and if you convert in normal decimal form, so it will come at 2. Similarly, if you can see here is 3 permissions are there. So it is 1, 1, 1, and it is basically 7 in the decimal. So you can see here we have 7 first, like 7 is basically all these permissions are there. Then we have 1, 0, 1. So 1, 0, 1 is that 5. And then again we have 1, 0, 1, that is 5. So that's why it is 7, 5, 5. You can see 7, 5, 5. So I am hoping that you are clear with it. So 7, 5, 5 is the same permission, but it is in numeric form, not in string format. Okay. Now we can obviously change the permissions. You can see there are lots of permission as well. You can change it. And for changing, we basically use chmod command. Okay. So particularly this command, chmod g-w and file name. What it's saying? Ki chmod, it means I want to change the command permission. What permission I want to change? I want to change the permission for group. Okay. And what I want to change? I just want to remove write permission to this particular file. What I want to do? I want to change the permission of group that he was not able to write because I am minus subtracting the write permission of a particular file. ठीक है? Note that you can create a directory using make directory command. So mkdir basically used to create a directory. So let's say I am just at, I am at the home directory. I just will create a directory mkdir and let's just create AAA. Cannot create AAA, permission denied. Okay, so let's go to some other location. Let's say just we go to home directory. Okay, CD, I just did CD so that because we have writing permission here, this is my college window. Okay, now here we can create, so let's create mkdir and then AA. Now I created, I just do ls command and you can see there is a directory called ls AAA, and just let's see the permission of it. So I just did lsl and you can see we have this much permission. First thing first, it is a D. What D means? It is a directory. What it is? It is a directory. Correct? Now there are three separations. 3 here, 3 here and 3 here. Now, first thing, it is for owner. The owner can write, read and execute, obviously. Then group. So group, what it can do? It can read, write and execute. But the other users can able to only read and execute but not able to write or change. Okay. Now I just want to let's say change the group permission. Okay, I just want to remove the writing permission for a group. I don't want to any team to basically write a file. What I will do? I will do chmod group. I just want to remove write permission. File name AA. I just did it, executed successfully. After that, I just rerun the command ls-a, and you can see my permission has been gone for reading. So someone who belongs to this group can't able to read this particular file. Okay, so I hope you got it. Similarly, I can add also. So again, I will just go to that particular command and I just will control C GW, and again I just did this, and you can see again it can able to write the permission. Okay, just let me clear the screen. Default permission, like I just created a directory and you was able to see that I had a default permission to that particular thing, and it is basically provided by umask, which we will talk sometime else. Okay, we will discuss later. Now we are writing commands. Okay, so I think let's there are little bit more theory, and then we going to see many commands. Okay, so command order. Okay, so we can give these options by any order. Like I was doing chmod this, right? But we can give it to any order. Option in the middle is a good practice, that whatever option you give, just give it in middle. And what I will say, like any order, you can write it like ls/ideal. Ideal basically, see, if I do /l, it give me with permission strings and everything. If I do /i, it will give me with inode number only. Okay, and if I do /d, so it just gave me the path, current directory is there. Okay, now what I can do, I can combine this. So ld, if I say, so you can see I am getting, so ld command works with like other thing. So previously I was just typed a d and I was showing this only, right? But now I am getting the permission string of this particular dot. Okay, so d is basically used with it is not solely used, it is used with some other command. Then ls-id I can do. So you can see I am getting this node, and let's me just go back to this particular directory so that you can understand better. So if I do this, where I am, okay. Now if I do /i, you can see this, but I can also do /id, and you can see I have this. And also you can see, let's say write a file name, let's say boot, and you can see I can get this thing. Okay, I know number and this. There are several. So similarly, I can combine LID or IDL, like combine all three. Okay, all three commands. Let's say /IDL for, let's say sys. So you can see sys has all these. Okay. Similarly, we have ls-a also, which will show me /-a will show me all the hidden files, those files which starts with dot also, all these things. So that's why we are able to see here dot folder, parent folder, and this also. Okay, all that, right? Now also, like we can write it like ls/d, then file name, then -li. That is also fine. Like the best practice is to write all these options in the middle, then write the file. Okay. Now, this is something I will just tell you in a moment. I just want to talk more about this proc directory. Okay. So here we have a proc directory. You can see here, this is a proc directory. So let's talk about it a little bit. So let's go to proc directory and just do ls. There are many files. Okay. Nice. Let's do ls-a and ls-lis. Yes. Now just notice one thing. What I said, there are many directories. Okay. And if you remember, I said what these numbers shows. These numbers shows the file sizes. So you can see all those files are basically 0 in size. Okay, there are many files, and you can see all these files are in 0 side. All these are in 0 side. Okay, and just let me just open one of the files. Okay, so let's see. We can open any one file. I do a cat command. Cat command basically we used to see the inside content of the file. So I just did cat version, and you can see I got this. Basically, cat is used to read a file. So what it means, that version contains some data, and if it contains data, then file size should not be 0. Let's say let's go to some other file. Let's say partitions is a folder. Let's open it. So I just did do cat partitions, and you can see there is some data. Okay, there is some data, but it is 0. So what I want to say is basically that /proc is a magical folder. Okay, the proc file system is a Linux. In a Linux is a virtual interface. This file is basically a interface that provide access to information about running processes. Okay, this whole folder provides information about running processes. It's a key tool for system administration and cybersecurity tasks. The files are only the placeholders. What these files are? These files are only a placeholder. That's why these are 0, which shows some information, but it is not real file or directory. These all are not real file. You can see the size of this particular file, kcore. You can see it is 140 terabytes. Okay, my system is basically 256 GB, and it is 140 terabytes. So it is not possible, right? How can we store the 256 GB this 140 terabytes of file? So it is basically a file. It is known as the magical file. It is not actually file. It is just a placeholder which contains information or process IDs on something. Okay. Similarly, there is a sys folder. Okay, it is a virtual directory that contains information about devices connected to your computer. So if we go on CDs, I just clear it out, ls, and then cd.sys, and just clear it out and else. So these are the files, let's say kernel, hypervisor. I just told you about hypervisor, right? Modules, power, kernel, devices. So these file contains the information about the connected devices to your computer. It is similar to proc and dev directory, but it is used to view and manage devices, while dev folder is used to allow other programs to access devices. Okay, so there is a dev folder also, you can see, and this is basically used to provide what other programs, allow other programs to access the device. Okay, so these are the theory, and now let's move to some commands knowledge also. Okay, so I just clear the screen, and the very first command that comes is that pwd. So what pwd does, it basically shows the path of the current directory, in which directory I am. So let's say I just go to some directory. Let's say I am at LA, I just go to opt, and I don't know where I am. So I just do pwd and it will show me that yes, I am at /opt directory. Let's say I go here and I just clear it out and I just do pwd. So where I am at the home directory. Okay, so pwd is used to show the path of the current directory. Similarly, ls, you are aware, it shows the list of all the files in the current directory. So that's how I showed. This is the ls command which you use to show all the files on the directory. Then we have some arguments with L, like some options which we can use. That is /ls-a. It shows all the hidden files. So if I see ls-a, you can see there are many other files as well. That is SSH profile, local, cache, bash rc, bash logout, current directory, parent directory. So all those hidden files it will show. ls.i, it will show all the files with link nodes, node ID. So if I do ls.i, what I get? IDs. If I do ls.l, it will show me the file along with the permission number and linked node IDs. So if I do ls.l, it will show me permission, host, group, linked node IDs, timestamp, last modified, and file name. Also, yeah, you can see link nodes also. ls/ld and directory name will show permission string and other details of the directory only. So let's say I have a bpt folder. So let's do ls/ld and let's say bpt one underscore problem underscore one. And you can see for bpt1, for like that particular directory name, it is showing me all the details for only that particular. Like if I want to check only for this particular directory, I will just write this. Now there is something called ps. PS basically shows all the processes running on my system. So if you do, I did ps. So you see basically a bash command is running. So current running process is basically what? Bash terminal and ps. Okay, these two. Then uname shows the operating system name. So let's say I just did uname and it is saying that it is a Linux operating system. Okay, so that's then there is clear command. Obviously I am using it again and again. You know that it's used to clear the terminal. Mkdir basically used to create a folder. So if I say mkdir my campus, so it will create a my campus named folder. I can change directory into cd.mycampus. Okay, I can go to like this directory by tapping cd, and I am currently, if I write pwd, I am at my campus directory. Similarly, touch is used to create a file. So let's say I say touch and just create, let's say my campus.txt, and I can just list out and you can see my campus.txt is there, and it is an empty file in my campus directory. It is an empty file. Okay. Date. So date is used to basically see the current date timestamp basically. So date you can use to see that. Then there is calendar, cal. So cal is basically show us the calendar of the current month. Okay. Now with cal we can see calendar of any month. So let's say I just say cal August 1947. So we can see the calendar of August 1947, and we can see that 15 August is there. So we can see all these stuff, and it is basically it takes arguments like arg, or you can give number also, cal 2/2001. Sorry, cal 2001. So you can see 2001 calendar is here. So this is how it works. Okay, and let's say if I try, I'm not sure, but let's try 07/2001, and you can see July 2001 calendar is here. So you can like give it that way also. Order does not matter. Then there is command called free. Free command shows the memory statistics. Let's say free. So it will show like, yeah, this memory, this much is memory, and this is matches swap memory. That is the virtual memory we are using. Now this is something which is not able to do it. So what I do, free and -h, it will show us in human readable format. That is, there is this much of memory, this much MB is used, this much MB is free, this much MB is the swap memory. Okay. So -free is used to basically show the memory statistic, but in human readable format. Then groups command is used to know the group, what are the groups running. So you can see here, this is the group which I am in, and if I check here, so there are many groups, you can see, right? Staff is there, everyone is there, local account app user is there, app administrator is there, like many groups are there. Then file, we can use file command to use basically what type of file one is. So let's say I am at my campus directory, and this is the text. Okay, I just want to know what type of file it is. So I just say file mycampus.txt. Oh, by the way, I just type my, and I just hit the tab button, and it will autocomplete my text. Okay, so you can see it is a empty file. It said what? It is an empty file, and it is text file. Obviously, you can see. Now we can copy a file. So cp command is used to copy. So let's say cp and mycampus.txt. Sorry, mycampus.txt. I just want to copy it, and let's say I want to copy it with some other name. Let's say 1.txt. So if I see here, you can see there is a duplicate file of the same particular file name. Okay, and it just duplicated the file with another file name. Okay, similarly we can just go ahead and just take the file, and we can copy it to some other directory as well. Okay, so let's say I just give it to, let's say bpt 1 assignment _1. Cannot create regular file. Okay, so there is no file. Let's say just create a file ls, and just create makdir make directory. Okay, let's just create AAA. So we have this AAA file, and which is an empty file. We can check it. What it say? It is a directory. Okay, and currently it is empty directory. We can go in this and just see it, pwd. We are in AA directory, and it is empty directories. So let's go back to by writing cd --dot. It will take me back to the previous folder. So I am in my campus folder. Okay, just let me clear it. ls for all the time. Now I can copy cp1.txt, and I want to copy it into AA. Okay, so I will just write AA. Cannot create regular file. Okay, I don't know. Okay, so it is sent to, it is basically copied to AA directory. So let's go in AA directory. Just check it, and you can see there is one file, 1.txt. Okay, so let's go back to our file. Now, so I just told we can copy with the name, so it will duplicate. We can copy it into some other directory. Now we can move the file to some other directory as well. So let's say ls was there and I want to move 1.txt or let's say mycampus.txt inside AA folder. So what command I will use? I will use mv mycampus.txt, or I just say directory name is AA, and you can see it is moved to that folder cd.aa, and we can check that my campus is here. Let's try this thing. I haven't tried it, but let's say at run, okay, and it went to this folder, came back to this folder when I did move particular file name to dash dot, basically parent folder. Okay, so you can see that it is working. Now what if we do, let's say this is the text and I want to move it to same directory, like we did it copy, right? So if I do this here, so let's say mycampus.txt and just I want to write to mycampus kmpus.txt, okay, and if I see, so see what happened. Previously it was mycampus, it get renamed to mycampus. So mv file is used to rename the file also if we did it in same directory, okay. So it will rename, and if we have given some directory path here, it has moved that file to that particular directory, okay. So yes, then we can remove the file, okay. So let's say I want to file remove, so I will say rm, let's clear it out first, ls, so these are the file I want to remove 1.txt, so I will just write rm space 1.txt and it will remove y file. So you can see there is no file here. Similarly, I can remove a file without prompt by doing rm slash so let's say, let me just create a file again, okay, and I will just say rm dash I, okay, that is that I, and then I write the name. Sorry, there is a space left. Then it won't it basically what, remove regularly file, okay. I will say yes, and that it will remove. So what it does, it asks for prompt that do you want to remove or not, and if I like say yes, it will remove, otherwise it won't remove, okay. So if I don't want to let's say I don't want to get this prompt, okay, so what I will do, let's say again create a file touch 1.txt. See, if I do rm slash I and 1.txt, it asks for prompt. I entered nothing, so it is still there, my file is still there. Now I don't want to ask this prompt, I just do rm slash if, that is force, okay, 1.txt, and it should work. And you see there is no prompt this time and it is removed. Rm also works fine, okay. So we are there, and then rm dash r will basically do what, it will use to remove directory, not the file. For rm dash like for file we are using rm dash I or rm, and for directory, for removing a directory we will use rm dot dash r and then a, and it will remove the directory. So you can see there is no directory, okay. Let's make back it that directory, okay. So we can see we are back. Now alias, so as let's say I want like let's say ask every time whenever I delete file, but I don't want to write rm dash r every time, so I can do alias it, that is alias rm dash I. So if I, let's say if check let's say there is a command which shows all the aliases in our system. I just forgot the command name. Okay, let's move ahead and it will come, okay, in the file. So what I can do is basically, let's say rm rm is a alias. Okay, rm is basically, let's say, file man rm. Okay, so rm, what it does, is basically do remove file or directory. Okay, then there is -f, which forces, -i, which prompts. Okay, and yes, so there are many other things. Okay, that remove empty directory and everything. So yes, you can always go to man folder and you can read about the manuals. Okay, then chmod I just already told. And alias command you can use to give basically aliases. So let's say alias. So if I write alias, then all those aliases which we have set, you will able to see. So there is egrep, which is basically this alias. Then L is basically, L is used for ls.cf. LA is basically used for ls-a. So like we were doing those IDA, ls/IDA. So we can set a alias for that also. Okay, so chmod is there. Man command, you know what it does. There is a less command. Less command, what it does is basically help to inspect the content of all in one page. So there is, let's say, some text file, okay, which contains a lot many text, let's say. So with the help of less command, we can read the text page by page. Okay, just remember, we can read the page. Like I was using the cat command. Similarly, we can use less command to basically read the page by page. And I guess for this, I just want a file which contains a lot of text. Let's say we go to some opt directory. Let's say if we have something. Let's say I just come back, cd, and let's just go to proc. And let's say we just do let, and let's say we do something like this file. Let's just pick randomly. Okay, so permission denied, that is we can't read it. Let's do some other file, swaps. So you can see we got it something in a text editor format, and we will be able to read the file. Okay, so I'm just using left and right arrows to basically read file line by line. Okay, so you can see all this. So yes, less command is used to basically read files line by line. There is a more command also, and also you can like do this also manual. Okay, so less command, and you will see that less command is basically opposite of more command, and it is basically used to is a program similar to more one, but it has many more features. Less does not have to read the entire file input before starting. It does not read all the files at once. It just goes page by page. Okay, there is a more command. What it does, it filters for paging through text one on screen full at a time. Like it will help you to read file on depends on your screen size. Actually, it will show that much text which fits on your screen. Then tail command is there. Tail command, what it does, print last 10 lines of the each file to standard output. Okay, what it does, it just prints the last 10 lines of file. Okay, so let's say if I say, and I'm not getting some big file, right? So let's CPU info is there. Let's check it out. And you can see this. So it is basically the last 10. You can see WP starting list at this. Let's say do a less, okay, less on this particular CPU info. So you can see there are a lot of things here, and you can see I am reading it file by file. Okay. Yes, and up arrow, down arrow. So I can read it by page. Okay. So there are many things here, and what we did, tail basically shows last 10 lines. So if you count it, it will be exactly 10 lines. Okay. Similarly, more is also the same thing. Let's say do the more. and CPU info, and you can see the same thing. Okay, and there is more option also. Okay, so whatever fits in your screen, it will show only this much. Okay, in the terminal. Now, cat command basically what it does, concatenate files to standard output. Basically merges all the outputs and show you. Okay, cat command used to run read also files. Head command, head will do what it will do, print first 10 line of the file. Okay, each file ka first 10 line. Then there is WC, which prints new line, word or byte count for each file, and a total line if more than one file is specified. Okay, so WC command, what it does, it just prints new line, word or byte count. Okay, there is which command will tell you there where the location of file where it is located. Okay, let's say I just want to say which ls, so it will say that yeah, this command is located at user/bin/ls folder. Okay, so every command is basically some logic which is written and which is stored in some script file. Okay, so every command is a script. Okay, so ls is stored at this particular location. How we got to know about which command is located to which location? I will say which and ls. Okay, then there is more command, that is what is will give you a brief description. So if I say what is ls, it will say it is used to list the directory control. Similarly, what I can say, what is man, it is used to an interface to the system reference manuals. Correct? That was like what I've seen. Apropos is basically search the manual page names and description. So let's say I just want to search like what are all those commands which shows me a list. Apropos and all these commands will show some list, like list open files, all those containing list. So it will give you all the commands which contains list in their use cases, like this one you can see, right? Then which command we already covered it. Info is used to read the documentation in the info format. So let's say info, and you can see documentation. Okay, all the documents, all the things here, kernel and everything you can read here, info file. Then there is help command, shows shell bulletin. Okay, help command, you obviously know what it will show. Then there is type command. Type command will show the type of a command. So let's say if I say type ls, so it will show this is a alias. Yes, that's what I was saying. Ls is alias to ls-color auto. Okay. Similarly, I could say type rm. So it will say rm is hashed to user/bin/rm. That is, this is particularly a command which is set by come with the Linux, and it is from that particular directory. Then ln-s. So ln-s, what we did, what it does, basically it creates a symbolic link of file 1 to file 2. I just discussed what is symbolic link and what is hard link. Yeah, so let's just show you. Okay, let's me just show you this particular thing. So let's say there are many files here, and let me just do this. Okay, so not this, let's say just do this. I just want to know the soft links and hard links. Okay, you can see every number is there. These are the link node numbers. Let's say I just do ln-s. Let's say take AAA. I just want to create a soft link to my campus. Failed to create symbolic link, my file exists. Okay, sorry, the file already exists, that's why it's not creating. Let's say .txt, and just let's check it. Sorry, I just check it like -i. Now notice this is my campus file, and it is a symbolic link. How I will know this? Just -l, and you can see my campus is directing to AAA. That is, it is a link to AAA file folder. Okay, clear? ls, and just let me delete it. So I will do rm mycampus.txt. Okay, so it is removed. So yes, you saw the demo, like how we can create a soft link. Now let's create a hard link. So for hard link, creating hard link, you use to ln command. So let's do ln command, and I want to create a hard link again, AAA, and let's say my campus. So already not allowed for directory. Let's say my campu. Sorry. Let's say just do mycampus.txt. What is it? Hard link not allowed for a directory. Okay, sorry. For directory, it is not allowed. So let's create a file. Okay. So let's create some file named touch mycampus.txt. Okay, I just created one file. Now let's put ln mycampus.txt and let's say directory. Okay, it's successfully executed. Let's say check I. So I just did my campus and directory A. Okay, just a second. What I did, let's create one more directory, more file. My touch my campus 1.txt ls, and just let's do one more thing, that let's say just copy this ln my campus.txt and just let me give it to my campus 1.txt. It's saying a hard link already exists. Okay, let me just debug it quickly what it's saying. So we have this mycampus.txt is here, and you can see mycampus1.txt is here. And let me just create it ln mycampus.txt. And you can see there is one more file, hello, and let me just check here. Now see what it does. What I did, just ln mycampus1.txt, and I just created a hard link to hello. So when I created a hard link, you can see the inode number 12609, and just check the hello inode number. It is same. That is, it means both the files are the one file. There is the same file. It's just a placeholder, a hard link. Okay, a hard link. So I hope you got the concept of hard link and soft link. Then stats is there. Stat displays the file or file system number. So let's say I just missing operand. Okay, so like I don't think it will run on my VM. So I can run it on my local machine, and you can see stat width showing me all the statistics like the inode number, okay, number of links, hard links and soft links, permission, user name, timestamp, okay, last modified, everything it is doing. So a stat will show you all the data related to file system status. Then there is du. Du will summarize the disk uses of the set of files recursively for directory. So du can show you basically how much disk uses it, all the file doing. So it is doing like 16 KB or something. All these files are empty files, so that's why. So it shows like how much disk use thing he uses. Then slash proc is sudo file system, and slash system is the virtual file system which exposes the kernel and driver information. Okay, so these are the pretty much it about the Linux. You will know how to learn how to basically navigate through Linux system and everything. So I hope you got it, and if you like the video, please do hit a like button. Okay, also subscribe to channel if you are new here, and I will see you next time. So take care.